Hi, thank you for your interest in our poster. My name is Jingyi. I'm a PhD candidate at Utility Medicine. This is a quick overview of our work. OA is a common joint disease that includes mechanically mediated cartilage degradation. People have found regional variation in cartilage mechanobiological responses, subfilial material properties like modulus and permeability, and also volume loss during the progression of OA. However, regional variation in cartilage failure properties have not been established. Therefore, the goal of this study is to quantify differences in compressive failure strain and stress of porcine articular cartilage. So how do we do that? 19 pigs were randomly divided into two groups. Sex was also randomly distributed. They were fed either a normal diet or a vitamin D deficient diet in the nursery phase. After that, all pigs fed a normal diet until euthanized at week 24. We then collected the full-thickness cylinder cartilage samples from the 5 regions of interest, which you can see in the figure below. Samples were loaded at 1% per second until 80% engineering strain, which is sufficient to break most of the samples. 2 raters independently identified the first yield point on the strain stress curve for each sample, and put the failure strain and stress at the point. The interclass correlation coefficient of the results were calculated. The yield point is defined visually, as where there was a disruption or a sudden change of slope. The red circles are the yield points we defined. As we can see in the red circle of the representative PAT curve in the middle, the change of slope can be very subtle sometimes. After having the failure strain and stress for all the samples, we investigated the effect of anatomical region, sex, and also vitamin D deficiency. These two figures showed the average failure strain and stress of all samples by region, because neither diet or sex significantly affected the results. Anatomical region affected failure stress but not failure strain. The average failure stress was the highest in PAT region, which was patella. We also observed that samples showed 4 primary failure types. As you can see here, figure A is a representative figure of the parallel cracks, B is for branched cracks, C is no visible crack. Some samples also broke into multiple pieces after testing, which we didn't include the figure here. A higher percentage of parallel cracks were found in the FCL region, while more samples from the PCL, PCM, and PAT regions displayed branched cracks. PAT was the only region in which some samples did not show any visible cracks. In summary, the results indicate that the patella need higher stress to fail, which could be a factor enabling surgeons to keep the native patella instead of performing patella resurfacing during total joint replacement surgeries. Previous studies reported a lower compressive modulus in patella, indicating a potential uncoupling between the cartilage subfilial and filial properties. However, studies with the same tissue sources from the same region are needed. While the rates of single medial side OA are higher than that of single lateral side OA, no differences were found between the failure properties of the samples from medial and lateral sides in our study, suggesting the observed differences in OA rate must be due to other factors, such as load distribution in the joint. Lastly, the interclass correlation coefficient between the two raters is 0.68, indicating some limitations of the visual analysis process. Even so, we believe the intrinsic regional differences in cartilage failure properties found in this study can provide some insights into the effect of anatomical regions on the initiation and progression of OA. Thank you again for listening, and please find us on Twitter.